In this module, let's dive into another advanced concept, and that would be mix-ins and custom composition functions, or to be precise, the general topic and idea of reusing code, both with the options as well as the composition API. Because the bigger your projects get, the more components you have in your projects, the more often you'll face scenarios where there is some code duplication across components and you would wish for a solution to reuse code, to share code across components. That will be the focus of this module. To be precise, we'll dive into a general overview of reusing things in Vue apps and which different concepts we have when it comes to that. And we'll then explore two main strategies for reusing code across components. And that will be mix-ins for the options API and custom functions or custom composition functions when using the composition API. So let's dive in and let's explore our options here. For this, I again prepared a little starting project for you. It is a simple project which you can start as always with npm install and npm run serve. And when you do so, you will see this on the screen. We got two dummy components here for adding and deleting a user, presumably. And when we click add user, we open an alert, a modal with add a user and the text asking us whether we want to add a user. And we can close this by clicking on the backdrop or by clicking on the close button. And when we click on delete user, we see almost the same dialog, the same alert, but with a different content, a different text. And therefore here in app view, I'm adding add and delete user, these two components. And in these components, I have my alert component added as a local component actually in both components. We could add it as a global component as well, but here I went for the same component added as a local component in two different components. And besides that, add user and delete user are very similar. They got pretty much the same logic in them, but they got a different template, of course, because that is where these components differ. And that already brings us to the core topic of this module, reusing logic and code. And for that, let's start simple. What can we reuse in a Vue application or in any web application if we think about it? Well, for one, that's of course our HTML structure and styling. This is something which we often reuse on our page. We often have different parts on our page which actually use the same HTML structure and styling. Think about list items where every list item looks the same. But we also often want to reuse logic and events which we might want to handle. And that's exactly why we have this components concept. With this core concept built into Vue, we have a powerful way of encapsulating structure, styling, and logic into a component and then using that component wherever we need it on the page. And thanks to props and slots, we can still customize this component to a certain extent. And in the end, that's what I'm doing in this mini app here as well. The user alert component is a reusable component which defines the structure and styling for a backdrop and the overlay. And then I'm using this component in both the delete user as well as the add user component. And these components themselves, of course, are also encapsulated pieces of HTML code and logic attached to it. And that is really the idea of components. We have HTML structure, styling, and possibly also some logic, like here for emitting this close event in the user alert component, which is all encapsulated into one reusable building block. Now, that's nothing new though. We worked with components for hours and hours already at this point in the course, and therefore that's nothing new. But it is the core concept when it comes to reusability in Vue. But it doesn't stop there. That is something we learned thus far. Now here's the new part. even with components which are great for having an encapsulated template and logic, customization options with props and custom events and slots, even with those components and even with this powerful concept, we sometimes are left with some code which we would want to reuse, but which we can't share as easily. Because what if we have two components that have related or similar logic in them? For example, the user list component with a search method, data related to search, and a watcher related to search. And then we have the same logic in another component. In such cases, creating a new component which has this combined logic might not always be possible. And therefore, when using the Options API, you have a concept called mix-ins, which basically allows you to share data, methods, computed properties, watchers, lifecycle hooks, whichever configuration you might need across components. So therefore, let's explore mix-ins and let's see how they can help us here in this example project. In this example project, the logic which I would want to reuse can be found in the add and delete user components. There, I basically have the same data and methods and actually also components option if you take a closer look. Now, you might be able to reuse this logic by creating some wrapper component. But another powerful tool for easily sharing this configuration across both components are the already mentioned mix-ins. For that, I'll create a new folder, mix-ins. The name is up to you, but I guess this name makes sense since I'm going to store one or more mix-ins in there. And I will add the alert mix-in file, or just the alert.js file. The name is up to you though, how you want to name this file. And in this new JS file, so not a .view file, but in this JS file, I want to store my shared config logic. And in this case here, it's actually an extreme case, the entire config objects for both components are exactly equal. They're exactly the same. So therefore, I will actually grab this entire default export here, copy it from one of the components, and go to the alert.js file and paste it in there. So now in alert.js, I'm exporting this object as a default object. Now what's the advantage of this? Well, now we can use this as a mix-in in those components. So for example, in add user, there I can now import the alert mix-in, this name is up to you, from going up one level, diving into the mix-ins folder, alert.js, and now we can remove all the code here so that we're left with the empty config object and add a new option which we haven't used before, the mix-ins option. And this takes an array where you add all the mix-ins, so all the shared code you want to apply to this component. And here I add my alert mix-in. And I'm going to copy this now, go to delete user, and add the same code there, replacing the existing config object. Now with that, there's just one more tweak we gotta do. I get an error now regarding my user alert. This import here is not required in delete user and add user view anymore, but we have to add it in our mix-in because here I'm referencing user alert. So here I'm going to import user alert from going up one level, going into components, user alert.view. With that, I can save this and reload, and we get a warning, failed to resolve component. This mix-in concept here will work, but actually not for components. If you got components that should be registered in a component, this components option cannot be shared through a mix-in. So therefore, we actually have to remove this and remove the import we just added and bring it back into our custom components, into our custom component options here. So re-add components pointing at user alert and re-add the import. Yes, I know we just removed it, but it is important to understand what you can and what you cannot share through mix-ins. and component configuration can actually not be shared. So let's quickly re-add it to both our add and delete user components and save everything thereafter. And with that though, if we reload, this will just work. And it works as before, but there is one key difference. Now we got way leaner add and delete user components, where the config objects simply contain the components option and then the mixins option, and all the logic we had in both components before is now in our mixin. And with these mixins, you can share all the component options you typically have, with the exception of components as you saw here, but you can share data, computed, methods, watchers, whatever you need there, it can be shared through mixins. And therefore mixins can be a powerful tool for making your components leaner and sharing reused logic across components. Mixins can be powerful when working with the Options API, as you saw in the last lecture. It's also important though to be aware of how mixins are merged with the options you define in your components where you use them. Thus far, I only have one mixin in each component, and I got no other options besides the components option in those components. Now you could add more mixins, but you could also have more component options. And let's say I also had a data option here in the delete user component, and in there I return a data object with some other data, maybe with the alert title, let's say. Delete user, that could be my title, and now I want to bind alert title to the title prop on my user alert component. Of course, we can do this with a colon and then point at alert title, which now is a data property of this component. There's just one important question. Will this work? After all, the mixin also provides some data. So which data wins? The one of the mixin or the one of the lead user? And if one of the two wins, does that mean that the other functionality breaks? Well, let's see. If I reload and I click delete user, the alert opens and we see that title, which I just defined as a data property of the delete user component. So actually, no data option wins, instead view merges the data. And that's important. This is a built-in mechanism. When you have a mixin, the options exposed by the mixin are merged with the options you have in your component. So for example, here in the alert mixin, I have this alert is visible data property, and by default it's false. Now this is merged with my component, and therefore in the end my component has this property as well, because I'm applying this mixin. But I could also add the same data property here to the data of the lead user and set it to true, which is a different value than applied in the mixin. And if I do that and save it, we see when I reload my app, this alert is open by default. So this means that my component option, where I set this to true, hence making sure that the alert is open by default, this component option overrides the option set by the mixin. And that's indeed how Vue merges mixins with component options. The component options win if there is a clash. By default, data is simply combined, but if you have, like we have it here, for example, the same data property in your component as you have it in a mixin, the component option wins, not the mixin. This is how Vue merges the data between component and mixin. Now, besides mixins as we added them thus far, or as we added it thus far, which is added locally to a component, you can also define global mixins, which affect all components, and not just the components where you explicitly add them. Though, to be honest, global mixins probably have a very limited use case. Now, one use case could be some logging or analytics functionality which you want to add to every component. For example, to know when a component was mounted, anything like that. For that, we could create a logger.js mixin file in the mixins folder, and in there export our mixin object, And in this object, now I don't want to change any data, but instead I'll add the mounted lifecycle hook, which of course can be added to any component, and you can also define it in a mixin. As a side note, if this mixin would be merged with a component which also has a mounted lifecycle hook, both lifecycle hooks would execute, the one in the component and the one in the mixin, with the one from the component being executed last so that it is able to override any changes made by the mixin. But that's just a side note. Here, I'm defining mounted in this mixin, which I want to use as a global mixin, and for the moment I will just log mounted here. So simply some logging for me as a developer. Maybe you want to store something in some database here, some analytics data, things like that could be done in a global mixin. So here I'm just logging, and now we can register this as a global mixin by going to our main.js file, where we also define global components and so on. Here we can import the logger mixin from /mixins logger.js, and with that import, it's simply added by calling app mixin. And you probably see a pattern. We had app component for global components, we have app mixin for global mixins. And we simply point at our import here, logger mixin. Now this registers it as a global mixin, and if we now save that, I get my alert here, of course still, but we also now see mounted in the developer tools. And we see that whenever a component is mounted to the screen, so for example, whenever we open a dialog. And these are global mixins. As I said, probably a very limited use case or a limited number of use cases where they can be useful, but still something to be aware of in case you have some functionality that should be added to every component in your application. Now that were mixins, a very useful mechanism for sharing data and functionality across components, either across all components with global mixins or across a few selected components by manually adding mixins to components. But mixins have some drawbacks, or at least one possibly bigger drawback. If you build bigger applications, far bigger than this demo here, and you're maybe also working in a team, mixins can make it harder to understand your code, your component structure, because it's not always obvious where some value is coming from. In our alert mixin, we got the show alert and hide alert methods. In our delete user component, we don't have these methods, of course, because they are in the mixin. But we are calling them from inside our template. Now, the problem with that is that here in this simple demo, for us, since we're the only developer who worked on this code, it's obvious where this is coming from. But think about bigger projects, where one component maybe is not just using one, but let's say 5 or 6 mixins. And you're maybe also working in a team with many developers working on the code base. Then it's not always as obvious where something is coming from. If show alert is coming from the alert mixin or maybe from the error handling mixin, which you also might have. And that can be a problem. With mixins, bigger projects, bigger code bases can be harder to manage. In addition, you have to take care about this merging behavior. And in case you have a scenario where the default merging strategies don't fit you, yes, you can override them, but that's a lot of extra care you have to take to ensure that mixins work correctly. And even if they do, you still are left with the problem of not immediately seeing where some method or where some data piece is coming from. That might not be a problem for you, especially in smaller projects or if you're working on your own. But as I said, in bigger projects, it could be a problem, and that's why Vue.js has a solution for that, and why Vue.js actually has an entire alternative way for you to write your components. Instead of setting up data, methods, computed, and watchers as you learned it throughout the course, Vue offers an alternative way, the composition API, which I already covered in the previous course module. And you might remember that in that last module, I already mentioned one possible downside you might face in bigger Vue apps when using the Options API. So the way of building components with data, methods, computed, and watch, which we used in the majority of this course. It's a great way, but reusing logic can be tricky or cumbersome because we use mix-ins for reusing logic when using that Options API, and for the reasons I just mentioned, that can be problematic in bigger apps. And with the Composition API, we have a nicer way of reusing logic across components. Because whilst we have mix-ins for sharing logic in the Options API, we have custom composition functions when working with the Composition API. So let's see how that would work. So now let's explore reusing things, reusing logic across components with the Composition API. And for that, you find the same starting project from before, but now it's using the Composition API. So data and methods was replaced by my setup method, where I then use refs and so on. Of course, make sure you go through the Composition API module first before diving into these lectures. So it's the same project as before, just using the Composition API, and therefore, of course, it also works as before. And previously, we used a mix-in to share functionality. Now, we can use a different approach. But which approach? Well, in the end, all this here is just code in the setup method. And if you leave Vue aside for a second, how do you typically reuse code in JavaScript? You might create a function that maybe receives some arguments and then maybe returns a value. That is how you typically outsource and share functionality in JavaScript. Well, this is just JavaScript, and the setup method is just one method with a bunch of different steps. So if you want to outsource some of these steps, we could create a separate function. And that's just what we're going to do with the Composition API. This wasn't a great alternative before, because with the Options API, it was not just one method with a bunch of steps, but it was an object with different properties. And therefore, there, using a function wasn't really an alternative, but here it is. So I will create a new folder next to components, and now it's up to you how you want to call this. I will name it hooks, because sometimes these Composition API functions are called hooks, and that's why I will follow this naming pattern. Other names which you might encounter for these special functions, which you use in conjunction with the Composition API, would be composables or custom composition functions. So hooks, composables, custom composition functions, that's the same thing. It's a JavaScript function that very likely uses some Composition API features like refs or computed properties and so on, which then is meant to be called inside of the setup method. And as a side note, we already used such functions, not built by us, but by the Vue router or the Vuex team, to use the route or router object in the setup method, for example. You saw that in the main Composition API module already. So in this hooks folder, I'll add a new file, again an alert.js file, though of course the file name as before is up to you. And in here, I'm going to create a function. And now here's a special naming which I want to use, which you typically use for these Composition API reusable functions. The function name should start with use and then something that describes the function. So here I'll name it useAlert, because this function will allow me to use alert functionality inside of the setup method. So your custom hooks, which you plan on using here to share code across setup functions, should start with use. It's still a regular function though. Now what should go into this function? Well, in the end, I want to put all the code delete user and add user have in common inside of the setup method into this function. So we could just grab this entire code and move it in here. Now, since I'm using a ref here, I also have to add that import. You always have to import the things you're using in a file into that file. So here, since I'm using ref in this file, I also need to import ref in this file here. It's not enough that we're already importing it in another file. This is not how this will work. And with that, however, we're creating a ref here, thanks to the imported ref function. We got all that logic in here in this alert.js file in this useAlert function. Now that's good, but what's the advantage of this? Well, now we can export this as a default, for example, this useAlert function, just as it is, with all that code in it and with this return statement. And we can now go back to add user, let's say, and instead of importing ref from Vue, here I'll import useAlert from, going up one level, hooks alert.js. And we can now call useAlert here. And what this will do is it will execute the useAlert function, which has the code for creating a ref and for creating these two functions that change the ref. We also return an object here in useAlert, and that allows us to use these things which are created in the function outside of the function as well. Because in add user, just calling this is not enough. We still need to return an object in this setup method. This is not replaced by our own function here. And of course here, therefore, I still want to return what we're using in the template. So alert is visible, hide alert, and show alert. And useAlert gives us all these things. Inside of useAlert, we, by the way, don't have to return an object. It's our function, so we can return whatever we want. We could also return these three things in an array if we wanted to. We could have an array with 3 elements, where the first element in this case is our data, and the second and third elements are our functions. This is up to you. It's your function. So to make this clear, I will actually use an array here. And now, since useAlert returns this array, in add user, we can store this alert array in a constant. And we know the first element will be our data and the other 2 elements will be the functions. We can also use array destructuring here, which is a modern JavaScript feature, to pull these 3 elements out of the array and store them in new constants. So here I will reuse the same names we have here, though you could use different names because it's the order that matters here. But with that, we're saying pull out the first element of useAlert and store it in a new alert is visible constant, which is available in setup. Pull the second element and store it in a show alert constant, and pull the third element out of the array returned by useAlert and store it in a hide alert constant. So now these 3 constants here exist in this setup method, and therefore here we can of course return them. And the first element, alert is visible, is our ref here, this one. And since it is a ref, whenever this changes here inside of the useAlert function, the component where we use useAlert will also be notified by this, because it is a ref. And we're exposing this ref to the template. And whenever you do that, Vue is aware of it, and whenever that ref changes, these changes are reflected in the template. So it's a different mental model, but in the end, it's just a function which we defined on our own, which we're calling here. And we can now copy that code and do the same here in delete user. Replace all of that with the copied code and get rid of the ref import, but instead import useAlert from, going up one level, hooks alert.js. And if you save this, this should all work as before, but now with our own custom function here, our own custom hook. So this is how you can reuse functionality across components when using the Composition API. Now, we can do more than what we're doing thus far. For example, we can of course still also set up other things in setup. We're not limited to just using our reused logic here. We could again import ref here from Vue if we had some other data that should be changeable, and create our extra ref here, like the alert title, which could be a ref with a starting value of delete user. And here, theoretically, I don't need a ref because I won't add any logic to ever change this, but I want to show you that you could, of course, have extra refs, as well as computed properties and watchers, and anything else you can use in the setup function, no matter if you are using a custom hook or not. But with that, I can, for example, also expose my alert title here with the return statement to my template, and bind the title here to alert title. And we can absolutely do this. And this is kind of a similar thing to what I did before with the mix-ins. There, the mix-in was automatically merged with your other options. Here, we kind of manually merge it by simply doing one thing with our custom hook and doing other things in the rest of our setup function. Now, our custom hook is also able to receive arguments, by the way. Here, I got a custom hook function which returns something, and your hooks will typically always return something because you want to do stuff in the hook, which then can still be exposed to your template. And for that, your hook needs to make these things available to the setup method where it's getting called. But your hooks can also take arguments. For example, let's say for the lead user, the default starting value for alert is visible should be true, so that by default the alert is opened. This might not make much sense from an app perspective, but it's a great practice. With mix-ins, this was kind of tricky. With hooks, it's easy. It's your own function, so of course, useAlert may accept as many parameters as you need. For example, starting visibility. The name, of course, is up to you. You can even assign a default value here, let's say false, so that you don't have to pass in a value for this parameter when calling useAlert. This is a modern JavaScript feature, default parameter values. But now we can use this and assign this here to our ref as a starting value. And now, since we have a default value, we can still call useAlert as before, but we can also call it and pass an extra argument in for this parameter. So pass in true as a value for this parameter instead of the lead user. And as a result, if I save that, we start with the modal opened for the delete user component because of that different argument I passed in here. So your custom hooks are really flexible. You can accept any arguments you might need, and you can use all the composition API features in there, do whatever that hook needs to do, and then return to the component where you want to use the hook, what that hook should expose to the component. So now that we saw hooks in action, why could they be better or nicer than mix-ins? Well, I see two main advantages. For one, it's easy to make them configurable. As you saw in the last lecture, adding extra parameters is easy, and all of a sudden, your hook is very versatile and can be used in different components with different configurations, which is great. In addition, they fix one major flaw mix-ins have. With mix-ins, I mentioned that in bigger apps with more and more mix-ins, it's hard to see which data property and which method is added by which mix-in. With custom hooks, that's easy. I mean, the custom hook returns the things it wants to expose to a component, and therefore we have to accept these things, like here, where we get an array and pull the things we need out of the array and store them in constants. It's super easy to see that alert is visible, show alert, and hide alert are coming from the useAlert hook. So even if we would be using 10 or 20 custom hooks, it would always be easy to immediately see which feature and which data piece is coming from which hook. And that can be a major advantage in bigger apps and bigger components. Now maybe you remember that originally I showed a little bit of a bigger project as an example of why we might want to consider using the Composition API. I showed this example at the beginning of the Composition API module, and at the end of that module, we migrated that project from the Options API to the Composition API. Now, you find that latest snapshot attached to this lecture because I want to pick up on that. I want to start there and now talk about reusing functionality because that's something we haven't done in that project up to that point. We stopped when we migrated it to the Composition API, but now I want to reuse some functionality. And there is one main functionality which I would like to reuse. In userList.view, I got my search functionality, 2 pieces of data, a computed property, and a watcher, and this function here. And we have pretty much the same in projects list. We're dealing with different data there. Here we have a list of projects which we filter. In user list, we have a list of users. But besides that, it's the same functionality. So let's see how we can now use a custom hook to outsource this into a function which we can then use in both user list and projects list. For this, I'll add a new folder next to components, and I will again name it hooks, and in there I will add a search.js file. There I'll add a function useSearch following that naming pattern which I recommended. And I will already export it because I plan on using and calling useSearch in user list and projects list. Now, as I mentioned, there is a lot of functionality we have in common. So why don't we just go to user list and maybe grab all that code here. So the 2 refs, the computed property, available users, the watcher, and this update search function, and copy it into search.js into our useSearch function, like this. Now we need to add an import, because I'm using a bunch of features which are not available in that file yet. The ref functions, the computed function, the watch function, yeah, that should be it. So we should add an import, and import from the Vue framework. And there specifically, I want to import ref, computed, and watch, since these are the 3 functions I'm using in this file now. With that code should almost work. Not entirely though. One problem which we will face is that we depend on props users filter. Now in this function, props is not available. Even if we call it in our setup method later, inside of the scope of this function, props doesn't exist. But of course we can work around that. We can simply add a parameter and maybe name it items to have a generic function that works on any kind of items, no matter if that's people or projects. That's why I'm just naming it items to make it clear that this should work on any kind of array. And then we could use items.filter here and also replace props users with items in the other places here, like this. And I'll rename my users helper variable here to filtered items and use that in all the places where I used users to make this more generic. I will also rename the entire computed property to available items, because this is now no longer focused on users, but on any items we want to search. Now we will still have a problem though. The function which is passed to filter here has specific logic for filtering that will only work on our users, because here I'm filtering on a full name. In projects list, for example, I'm filtering on a title. Now there are 2 ways of making this work. We could accept this filtering function as another parameter, a filter function, which we then, for example, just pass here, like this. That would be one alternative. Then we have to pass in the function that should be used here from the place where we call useSearch. Or if we know that we will always operate on an item, but the property which holds the text we want to use for filtering has a different name all the time, then we could also just accept a second argument which stores that specific property name of the values we're trying to search in a given component. So then, for example, here we could add a search prop, or whatever you want to name it, parameter, and simply access user search prop. So dynamically access a property based on the value we get on this parameter. And maybe rename this from user to item. So both works, but with that we have a more flexible filtering logic here. Now, we also have a watcher here where we watch the entered search term, and whenever that search term changes, we trigger this function and set this timer. Now, here we can leave everything the way it is because both entered search term and active search term are refs defined in this function and therefore will be available. And update search should also work. So with that, the only thing we gotta do is we have to return a bunch of things so that we can use them in the component setup method where we're going to call use search. And as I mentioned, it's your function, so it's up to you how you return these things, if you bundle them together in an array or in an object. And here I'll go for an object. Before we saw an array, both is possible. Here I'll go for an object. And now let's think about what we want to expose to the component that calls use search. For that, let's maybe go back to user list, because that will be a component which will soon use this custom hook. And there, let's see what we're exposing to the template here. We're exposing the entered search and the update search function. We also rely on the available users here in our displayed users. So therefore, in our custom hook, we should absolutely expose the entered search term, the available items, and the update search function. So I'll expose the entered search term, the available items, and the update search function. That's what I'll return here in my use search function. And now we can go to userList.view, and for the moment, comment all of that out, and instead import use search from, going up 2 levels, hooks search.js. I'm not removing this view import up here because I'm still using a ref, a computed property, and no watcher, but a ref and a computed property down there. So we have to keep that around, but we can remove, and we should remove, the watch import because I'm not using watch in this file anymore. Just ref and computed. Those are still used in my setup method, even with this code commented out. But now here, we can call use search, so our own function here, and this function now needs 2 parameters. The items and our search prop. Now, the items, that was props.user, if you remember. That is what we used here before. So props user is what I want to feed into use search. And for the property, which we wanted to use for filtering on every user, that was the full name property, which we should pass in as a string. As a string because property names in JavaScript objects are strings. So we pass this in as a string. And then we get back some values here. In this case, we get back an object because I return an object in my custom use search function. And in there we'll have these 3 properties. So we can again use object destructuring here with this syntax to get the entered search term, the available items, and the update search function. Entered search term will be a ref, available items is a computed property, and therefore a read-only ref, and update search is a function. Now we can use these things here. For example, in displayed users, I'm relying on available users. this is now available items. And of course, we could rename this here in this setup method if you wanted to stick to available users, but I will just go with available items. The rest should be fine. And then here I return the entered search term and update search to the template so that it's available there. If we now save this reloads, but I see no users. That is just a typo I have here, though. I should pass in props.users, since users is my prop name here. So if I use that, then I am feeding in users, and now we see them here. Now sorting works, and what about searching? That is looking good, as you can tell. Here we are able to search and sort and select users just as we did it before, but now we're doing this with our own custom hook that supports us with that. And we got this use search hook now and can therefore get rid of all that commented out code. And now this line here, or these 3 lines, replace all the code we had in there before. And of course we can now use the same in projects list because that was our main idea. We wanted to have reusable code. So here in projects list, we can also comment out all this code here and also this watcher, which is related to searching, and also remove this function here. And instead import use search from hooks search.js. And now copy in that code which we used in user list. So where we call use search, but now I want to pass in a different value. Here it's not props users on which we want to filter, but instead it's props user projects. So let's pass this in. And we don't want to filter on the full name property on every user project, but instead on the title property. We can see this here in the original code, so we should feed this in. With that, we get the entered search term though, the available items, and the update search function. And we can now use this in the rest of the component. For example, here we're using available projects. That should now be available items. Here we're using entered search term and set a new value. Well, since we're getting the ref here, that should work. Assigning a new value here should work. It's a ref, we can update it from anywhere. Here, however, I now also want to return available items or still available projects so that I can keep using that name in the template, here for example. But I want to store available items in that available projects key. So I will not use this shorthand here, but instead store available items in this available projects property in this object we return to our template. And with that, yeah, I'm still importing a bunch of things which we're not using anymore. Let's maybe remove all the comments here so that this is a bit easier to see and to fix. Like this. And we're not using ref anymore. We got no other refs in here. We still got another computed property and a watcher, so we want to keep those imports. We also still use 2 refs, but we're not using the ref function anymore. So we can save that and get rid. And if I now reload, I get an error. Cannot read property projects of null. What could be causing this problem? Well, it's this line here. I'm passing in props.user.projects to use search. The problem with that is that we don't have a user selected initially. So initially, user is null, and I try to access projects on a null value. What could be workarounds here? Well, one workaround could simply be to create a new helper, variable or constant, projects for example, where I check if props.user is a thing. So if this is truthy, and if it is, I access props user projects and store that in projects. Otherwise, I store an empty array in projects. And then here I just pass in projects, which now is either an empty array if we have no user, or which is this value. Now this is looking better. However, now if I select different users, we always get no projects found. So it looks like there's something wrong with our code. And what could be the problem here now? Well, it's still related to those user projects. What did I say about props in the composition API module? I said that the props object is reactive, but the properties in there, the values nested in there, are not. Now what I'm doing here is when setup is executed for the first time, I'm pulling either the projects or this empty array. And that's it. Setup is not going to run again. If we select a user thereafter, this code is not going to run again. So projects will always stay this empty array. We need to react to user changing and update projects. And an easy way of doing that would be that we use a computed property here, take this code, and in the function inside of that computed property, we now return this code. By doing that, we ensure that computed, and therefore view, watches out for props, since it detects props as a dependency inside of that computed property. And whenever props change, and therefore the user here changes, whenever that happens, it will give us new projects. We can actually shorten this a bit. I'm already getting my user as a ref from props with this line down there. If we cut the line down there and actually move it up here, we can now just refer to user, which also ensures that this computed property is not re-evaluated whenever props change, but only when the user prop changes, which is a bit more efficient, though here it does not matter because we only have the user prop. Though that's also not entirely it. Keep in mind, user is a ref now, so we have to check user.value, and here also user.value. With that, however, it looks like it should work, but will introduce a subtle new issue. Projects now is a ref, right? Because it's a computed property, and computed properties are read-only refs. So I'm passing a ref to use search. In user list, we're doing something else. Here I'm passing in props.users, and as you know, the values inside of properties of your props object are not refs. So here, props users, the array I'm passing in, is not a ref. In projects list, what I pass in is a ref though. Now in search.js, I therefore sometimes get items which are a ref, and sometimes items which are just an array. Now I absolutely want the ref functionality here, because this computed property here should be re-evaluated when our items change. But of course, items.filter will not work if items is a ref. That should be items.value filter. And here it should be items.value. And here it should be items.value. But now, of course, we'll face problems when items is not a ref, like here in user list. There is a simple solution to this problem though. We can simply also use two refs here, like this, and pull out our users from two refs props. So the same approach I'm using in projects list, so that I can pass in users, which now is a ref, to use search. It's not required here technically, but with that we ensure that use search always receives a ref as its items and therefore will always work. And now you see we can switch between different users and see their projects. And searching here also seems to work. And if I switch the user again, that also looks good. Like this. So now we got this functionality working again. Now, however, with our own use search hook and therefore with reusable code. Yes, there were certain things we had to watch out for related to this ref reactivity thing, But after all, we were able to figure it out, and now we got flexible reusability thanks to this custom hook, which we're using in 2 components. Now there are a couple of notes which I still want to make about our solution here. For one, here in Has Projects, I'm also using props user projects. Well, since we're already extracting user into a ref here in this line, we can of course also utilize this here, user.value projects, and access that. One other thing I want to highlight is this watcher. Here I'm changing the value of the entered search term. Now keep in mind, entered search term is exposed by our use search hook. It's one of the values I'm extracting here. It's originally defined inside of that hook. Now changing things, changing a ref that's defined in that hook from inside the component where you use the hook is something you can do. It will work, as you can tell, but maybe it's also something you want to avoid. For one simple reason, to keep your code understandable and maintainable. If I see this code, I might think that entered search term should be a ref of this component, and I'll not find it there until eventually I see it's coming from this hook here. In addition, changing it here outside of the hook could interfere with other logic you have inside of the hook. It doesn't here, but it could in other apps and other scenarios. So therefore, a more elegant way of changing a value that's defined and used inside of a hook could be to define a separate function that is meant to be used if you want to change a value. And we got such a function already, update search. It takes a value and assigns this value as a new value to the entered search term. And in the end, that's just what I'm doing here, right? So therefore, I can just call update search and pass an empty string as a new value here, because that's what I want to do. I want to set entered search term to an empty string. And with this, I ensure that if I select a user and I'm filtering, I still reset this when I select a different user. So this watcher now still works and still resets my entered search ref, but now it does this in a better way, I would say. Now with that, I'm done with the search functionality though. As a final practice task for you, I want you to now think about a way of outsourcing this sorting functionality. We're only using it in one component, but theoretically that could of course also be used in multiple components. So try creating a custom hook for this. We'll do it together in the next lecture. Were you successful? Let's try this together. I'll add a new hook for this, a new file, sort.js, and I'll export a function, useSort, sounds like a fitting name, which in the end should later replace this sorting functionality. So this sorting ref, this computed property, and this function. Therefore, we can grab all of that, cut it here in user list, and actually move it over into this newly created useSort function. Now here I'm using a computed property and ref, so we should import ref and computed from Vue, so that these features are available. I'm also relying on available items.value, and therefore this should be an input, a parameter in this function. So I will accept available items here as a parameter. I'm also relying on full name for the comparison which item should come first. And that's of course very specific to users. Now here we're only using the sort functionality for the users, so we could leave it like this. But if we wanted a more generic sorting functionality, a more generic useSort hook, we might want to accept a dynamic value here, so that the sort property is another parameter we get, and here we then access this dynamic value so that any property name can be passed in from outside, like this. With that, however, we should be fine. And now we can again return our data and functions and so on from inside the useSort function to the places where we're going to call it. So here I want to return displayed users and sort, displayed users and sort, so that we can go back to user list and use that data there. I see in user list I'm also exposing sorting to my template, so therefore in useSort we should also return this sorting ref so that we have it available in the setup method of the user list component. And then here in the user list component we can import useSort from hooks sort.js and now call useSort here. And to useSort, I want to forward my available items. So the available items I'm getting here from useSearch. This is a ref, a read-only ref, if you remember. So I'm forwarding this to useSort now. And I also pass in this property on which we want to sort, which here is the full name. And we get back an object which we can destructure, where we will receive these three properties. So I'm copying them here, putting them in here, reformatting this, and now we have a sorting const, a displayed users const, and a sort const available here. Sort will be this sort function. It will point at this sort function, which we define here in useSort and return in here. And displayed users will be the displayed users computed property, and therefore a read-only ref. And sorting is our regular ref, which we define up here in useSort. So now we're forwarding sorting and sort to the template and displayed users as well. If we now save this, I'm getting an error that I'm still importing some things which I'm not needing anymore in the userlist.view file, because we're not defining any refs or computed properties anymore. So we can remove these two imports and just continue importing two refs because I'm still using that. With that, it compiles though, and I can see the app here, and sorting seems to work just as before. So if I give this a try, yeah, that seems to work. And with that, we now also would have a reusable useSort hook. Now, the goal with the composition API is not that you always need to outsource all your setup logic into separate hooks. Here, we're just doing this for practice purposes. It would be absolutely fine if you have some refs and computed properties and so on left in this setup method. Here, it just turns out that we just have these two main functionalities, which are now outsourced and which should now be usable in any component here which needs searching or sorting functionality. And that's the great advantage of the composition API, especially once you know about custom hooks. Because now we have a lean component here, we got reusable functionality, and that really allows us to build super huge components which are still maintainable.